Hello, myself Yamuna P. Welcome to Yamuna's Physics. Today we are here to discuss a topic 1.14 Gauss's law in lesson 1 electrostatics. Now this law was coined by the famous mathematician Carl Friedrich Gauss, and the contribution of Gauss was, you can't say by words actually, that much bigger contribution was Gauss's law to electrostatics. Because when you deal with discrete charges, Coulomb's law is okay. But when you go to continuous charge distribution, it's very tough for just using Coulomb's law. So that limitation was very simply overcome by a simple equation known as phi equal to q by epsilon 0, and lot many things are summarized in simple equation phi equal to q by epsilon naught. Let us see what is the inner meaning of writing q by epsilon 0. Now for that, please consider a point charge q. Just consider a point charge q, and it is plus q. So we have studied electric field lines are radially out. Through all the directions, the electric field lines are going radially out, or it has a spherical symmetry. So the electric field around it forms a sphere, spherically symmetric sphere, not circle. But on the board you can have only two dimensions. So we feel like a circle, but actually this is a sphere. Now suppose we have a radius r with a sphere that is known as Gaussian surface. It was simply an imaginary surface. Once you go to the result, once you go to the proof, nowhere in the result you will find a Gaussian surface. But throughout the process we need that Gaussian surface. When you say about Gaussian surface, it can be of any shape. Shape doesn't matter at all. But the condition is the surface should be a closed one. The only condition regarding the surface is it should be a closed one. And one more condition is there. The charge should be enclosed. The charge should be enclosed within that surface. That surface is known as Gaussian surface, and the charge should be well enclosed. Clear? Okay, come back. So this sphere I have cut into different solid angles. Solid angle in the sense you can just imagine about an ice cream, cone ice cream. If you put lot many cone ice cream together, it will be a sphere. So I tried to put the sphere as too many cone ice creams, cones put together. So one cone, the other one, the other one, the other one, of small surface area ds. So this ds are small surfaces of the big surface 4 pi r square. Total surface area is 4 pi r square, everybody knows. On that 4 pi r square, I cut them into small cones, each of surface area ds. Clear? And what I am trying to do is, I am just finding out this, consider the solid angle ds with the radius r. I just want to find out what is the flux emerging out through this particular surface. Just finding out what is the flux through this surface, only this surface. How to find out the flux through that surface? Too simple. You know what is flux? E dot ds, that's a flux. And what is E? It is written 1 by 4 pi epsilon naught q by r square. And E bar, definitely it's a vector. The direction is given by r cap. How to find r cap? This is the point where you need to find the electric field. Just place a test charge here. See that they are repelling each other. So it moves in this direction. R cap over here, this side, over here, this side, this side. So at each point, R cap at each point shows the direction of the electric field. So if this is the point, this is R cap. So R cap is given as direction of electric field. And about ds bar, I have told you it's an area vector with outward drawn normal to the surface. So this orange shaded area ds, n cap orange again shows n cap is a vector which is perpendicular to ds and drawn outward. Very important thing, outward drawn normal. So r cap dot n cap ds. Clear? So find out what is r cap dot n cap ds. What is r cap dot n cap? If both are in the same direction, theta is 0, and what is a dot b? A dot b is ab cos theta. So what is the answer? R n cap n cap cos theta. Mod r cap 1, mod n cap 1, cos theta 1. So what is the answer? R cap dot n cap is 1. So this information you know in first year itself. So we have r cap dot n cap as 1. So you will have 1. So the remaining is ds. So what is d phi through ds area? Through this area alone, a single ds, d phi equal to 1 by 4 pi epsilon 0 q by r square ds. Clear? Now we have how many such area? I don't know. We have lot many ds put together, then you will have 4 pi r square. That's the total value. So for 1 ds, this is the answer. So for total ds, take the sigma. Very simple. Take the sigma. So you have phi total. Taking sigma, what you will get? The total surface area of the sphere, 4 pi r square. 4 pi cancels, r square cancels. So the remaining q by epsilon naught. Very important thing. Q is enclosed charge. To specifically you can write phi total as q enclosed by epsilon 0. Clear? Charge is well inside the Gaussian surface. Okay? But this law arises a verification. That means if I say the LHS phi total is 0, what do you mean by that? RHS should also be 0. But 1 by epsilon 0 is never a 0 value. It is a value 8.854 into 10 to the power minus 12. Even if it is power minus 12, it's not 0. Therefore, what is 0? Q is 0. So we have to verify if LHS is 0, enclosed charge should be 0. So that NCERT is verifying in this manner. The same thing which is simple example. It is as follows. You have an electric field. Don't get bored or tensed by seeing all these writings. It's very simple. When I explain, you can understand these writings are too simple. I just want to explain. That's why I write in different colors and so and so. So please pardon me. That's the inner thought when I write in different colors. I want to emphasize certain areas. That's it. Okay. So come to the figure. You have the orange shades in electric field. It is uniform, equally spaced, parallel lines showing uniform electric field E. Okay. In that I have this magenta shaded or purple shaded Gaussian surface. Now one more thing. See, this Gaussian surface is cylindrical. This Gaussian surface is spherical. No matter, no problem. It's okay, comfortable. No problem. Shape is not a matter. Doesn't care in the case of closed surface. No shape, nothing. You can take any shape, but it should be closed, right? Come back. So this is a surface which is cylindrical in shape and it has three surfaces. Suppose this is a cylinder, one side, other side, the curved surface, right? So this is one side, this is the other side, curved surface. All the three surfaces, you draw the electric field and ds. Electric field obviously to the right, I have told you. What about ds? If this is electric field in this direction, here the outward normal in this direction, here outward normal that direction, here outward normal this direction, right? Wherever on the curved surface it is perpendicular to that, means theta is 90 over the surface. Here theta is 180 opposite. Here it is 0. Find out the values. Cos 0, cos 1, cos 0 is 1, Cos 180 is minus 1. Cos 90 is 0. Substitute, you will get it as 0. Look at this phi 1. What's the value of phi 1 here? What is phi 1? E ds cos 180. What is this one? E ds cos 0. What is this? E ds cos 90. Cos 90 goes to 0. E ds 180 is minus 1. Look at this, it is minus 1. So it is minus E ds. E ds cos 0 is 1. So that is E ds. Minus and plus cancels. 0 plus 0. The other one is again 0. So finally you get the total flux. What is this? Phi total. What is phi total? 0. If phi total is 0, what is the inference? Q enclosed has to be 0. For sure, we have not placed any charge inside the Gaussian surface. There is electric field outside as well as inside, but no charge is there inside the Gaussian surface. So explicitly shown, which proves no charges inside the cylinder. Cylinder in the sense Gaussian surface. So what are the main important things to remember on Gauss's law? Number 1, it should be a closed surface. It is named as Gaussian surface, no matter what shape it has. Okay. Next one, the charge. It should be enclosed. It should be covered within the Gaussian surface. Clear? It can reside anywhere, wherever it wants, but well inside the surface. So these two main points you have to bear in mind. It should be a closed surface of any shape, no problem, and the charge should be well enclosed. Hope it is clear. Now come back to Gauss's law once again. Gauss's law states that the flux of the net electric field, around this you have electric field, we have calculated net electric field, taken the net flux, not electric field, net flux of the electric field we have taken through the closed surface, and that will be equal to 1 by epsilon naught times total charge enclosed. The underlying words once again, charge enclosed, closed surface. Clear? So in a single equation, you can write it as phi equal to q by epsilon naught. You prove, this is how you prove. Verify, this is how you verify. Hope it is clear. Thank you for watching. Thank you for listening. Any doubts, please do have a comment. Thank you.